But I think they worked for the beginning of class yesterday. Page 2 said, hey, guess what? Opposite over adjacent is the same thing as y2 minus y1 over x2 minus x1. So opposite over adjacent, tangent, TOA is slope. And as soon as we saw that, tangent is slope, we were able to use it in lots of different ways. Now, kiddos, help me out, those of you that were in class, because we skipped steps yesterday, and you said that was okay. So explain to the sophomores, how did I go from here to here and here to here? Or why did I change? Why did I change? Yeah, Michael. Yeah, because what form is this? Standard form. And I wanted? Careful. Slope intercept. Point slope moves over. It's okay. Slope intercept, because then I can see slope m is 1. Plug it in, and then solve. And this was like, Chris, this was your example, the section in homework that you were double checking. If they give you the slope, just set equal to tangent and solve using tangent inverse. Yeah. Get the angle, done. If it's negative, add 180. Josh. Which one? Oh, alpha? Oh, right here, the fish. Because I did tangent inverse at both sides, and I got this guy, but I didn't want to call him theta because he's not the inclination. We don't use negative angles for inclination. So I called him another Greek letter. Remember the Greek alphabet? Alpha, beta, gamma, delta, epsilon, eta, theta. No, iota. I don't know. I get lost in the order right about there. All the way down to omega. Yay, the end. Anyway, so I just made it another Greek letter so that I could add 180 and actually get my inclination that I needed to have. This one was a little different. They gave you the angle, plug it in, solve for the slope. That one was unit circle, but you could have used your calculator. Kiddos, for homework, help us out. Did you ever have to switch from degrees to radians or vice versa? Okay, so keep your eyes open on homework. Some of them are degrees, some of them are radians. You got to keep your calculator mode appropriate to what's going on. This was a key example of, they didn't give you m, but they gave you enough to get m using the formula. Then solving, and here was our last example. We did not get to do one other example. Actually, it's missing. It disappeared somewhere. But the goal of this page was to find the angle between two lines. So we took out the page that Honors and I did trying to get to this formula. We're like, oh, all right, whatever, there's a formula. Let's figure out how to use them. What is this? Oh. Let's figure out how to use them. So the key difference here, it is tangent of theta, but here's the struggle. This is not just one inclination of one line. This formula is for the inclination, thank you. Taking the inclinations of both lines, taking the slopes of both lines, considering both lines and saying, hey, what's the angle in between them? So this is the formula for trying to find the angle between two lines, taking into consideration both their slopes, and that's why there's an M1, M2. Help out those of you here yesterday. Does it matter who's who as far as who's M1 or who's M2? No. Nah, just take it. Take one, make it one. Take the other one, make it the second one. Doesn't matter. That's the nice thing, the formula, the way it is arranged, the absolute value says, I don't care what order, just get them in there. So we found the slope after rearranging, found the slope after rearranging, plugged into the formula. It was messy. However, what could you do in your calculator? Plug it in all at once. Yeah, you could have just plugged it in all at once. Using that big old alpha y equals and absolute value bars around the whole shabam. You could have even taken tangent inverse of the mess and gotten straight to the answer. But I was also showing some of you, like me, we don't mind playing with numbers a little bit to make it easier on ourselves. So I play with the numbers a little bit to simplify the complex fraction. And then I had a couple people yesterday, thank you for all of your help on your calculators yesterday, guys, who were willing to plug in both the nasty version, tangent inverse of the bleh, and also the nice version. They said, hey, they match. And the final answer was 79.7 degrees. We could do another example, but for sake of time, I'd rather hear if there are any other questions from homework last night. Those of you that, hey, sophomores, if you want, you can write down homework. It's right there. For those of you guys that were able to start homework, anything else besides the ones that Chris asked? Oh, which is a good sign, sophomores, because what's that mean about homework? Not too bad. Not too bad, as long as you have your calculator, right? Otherwise, might be a little bit rough. As long as you have your calculator and you have your two formulas, m equals tangent theta and the angle between formula. Jackie. Pop in during lunch or after school and I can give them to you. Yeah. Because my TAs, I have TAs 3rd and 4th and 5th, so everything's done by. The only problem is I have no TAs before your guys' class, which is why. Okay, so that's it. Chris?
On number 52.
Okay.
It's kind of like another just making sure I'm doing everything right.
Okay.
I changed everything to y point. What was it? Point slope intercept form.
Uh-huh.
I changed 52 the two equations to the slope intercept form.
Okay.
And I did like the whole.
Can I double check your slope intercept form real fast just to make sure? If you guys don't mind going, I have it right here. So y is equal to, it should have been a positive 3/5 x, right? And then a minus 3/5. Because you subtract 3x, divide by -5, and then positive 3 divided by -5. And then the other one would be y equals negative 3/5 x plus, no, minus? Plus 12/5. Okay, double checking. Those are good? Okay, cool. Then what?
And then you did the tan of theta equals.
Because what were the directions in this whole section?
It was to find the angle of theta in radians and degrees between the lines.
Good. So find the angle between. So for those of you sophomores that didn't get to see yesterday's example, Chris is just, we're going through one right now. So we changed both the slope-intercept form. We can see our slope. So then, Chris, who did you make M1, M2, just so that I'm with you on it?
I made the top one M1 and then the bottom one M2.
Okay, so M1 would be that guy, and then M would be that guy. Okay. And then you were plugging in your formula, right?
Yes.
So is it okay if I put the tangent inverse, like I get theta by itself? Is that cool? Okay. Big old fraction. Technically, is it M2 minus M1 technically?
Yeah.
Okay. So M2 minus M1 all over 1 plus M2. And careful, you made one positive, one negative, right? Okay. So you could have just plugged in the whole mess using your alpha y equals, big old absolute values around everything. Just for everyone's sake, though, since complex fractions show up in math, I don't know, sophomores, were there any complex fractions on the pre-ACT? No fractions? No complex fractions? Maybe one or two? Okay. What was my trick? What was my trick for complex fractions? Yeah, find the little entrenched guy, right? Uh-oh, hold on. 5. Okay, so 5's good. Who's down here? Isn't that a 25? Okay. So I would multiply top and bottom by 25. If I was doing my cool complex fraction trick, just to make it pretty. And this is mostly for complex fractions when they show up. Just here's a way that we can practice them. The 5 and the 25 will reduce to 1 and 5. 5 and 3 is negative 15. The 5 and 25 will reduce to 1 and 5. Because remember, it's 25 over 1. That's minus 15. Chris, a common mistake on this one, if people were doing it by hand, would be to accidentally cancel these out and say 0. That's just a common mistake if you're not being careful. Not that you did that, but just in general. And then down here, 25 times 1 is 25, minus, a negative times a positive. Here, 5 times 5 is 25, which will reduce with 25, and all I get is 9. And so we'd end up with the same thing as tangent inverse of negative 30 over 16, but the struggle is what's outside of this whole formula. Right. So when we go to solve, you shouldn't be getting a negative angle and then having to add 180. Instead, you should just be taking tangent inverse of 30 over 16. I mean, you could reduce that, I guess, if you really want to, which would be 15 over 8. Yeah. And that should work out. That should work out. And guys, yeah, go to your calculator because 15/8 is not square root of 3 over 3, 1 square root of 3, 0, or undefined. So therefore, unit circle won't cut it. Not that we couldn't guess and be like, well, 15/8 is 2 and a little bit, and 2 and a little bit is somewhere between undefined, which is infinity, and root 3. So it's somewhere bigger than 60. I know that much. But Josh, yes, you may. Michael.
So with the calculators,
Yeah.
when would you know that
think about what you're doing in this problem. What you're doing in this problem is, why is everyone freaking out? Middle school maybe? Oh, that's why. Thank you. Okay, because they're all in the hallway okay, got it. Think of what you're doing. Aren't you solving for theta? So if you're solving for theta, your answer is going to be a degree or a radian. Let's say it's a test. Multiple choice answers are degrees or radians. How do you know which one they want? Look at whether there are degree marks or not. So if there are degree marks, be like, oh, degree mode before you hit enter. Or even after you hit enter, you're like, my answers aren't matching. Oh, I bet I'm in the wrong mode. So this one is you kind of have to know what kind of answer they want. And I think in general for this section, I was kind of leaning towards degrees because it's more practical, like with the mountain and the elevation and the inclines and the grades and all that stuff yesterday. So I was leaning towards degrees to be more practical every day. Anyone knows degrees, not everyone knows radians. But there were a few places in homework where they forced you to do radians because they gave you a 2 pi over 3, or they gave you a pi, and you had to then change the mode. Does that make sense? So if they give you a radian angle, then you have to change to radian mode. But if they don't give you a radian angle, then just stay in degrees unless you have a degree answer and you're looking and all the multiple choice are these weird decimal things. Oh, change it to radians. You're good. And then did I answer? There was one more hand. Chris?
Is it dangerous that I leave the absolute value until the very end?
Not unless you forget to do it at the very end. That's not bad as long as you keep writing it. The dilemma is with a lot of people, if it starts in their work, things tend to disappear as they go on without actually ever having been done. So as long as you're very particular about keeping the work written, then it should be attached in your brain that you wouldn't forget it. But if for any reason you ever stop writing, like grouping symbols or parentheses, or some people, and it happens a lot, so I'm not pointing anyone out, but sometimes just things disappear. And so if your grouping symbols disappear, then it could be a problem. Or if you're really messy and you don't know if it's a parenthesis and so you accidentally. But as long as you know it, you're good. You're good. But good question, bud. Because there's no real way to get rid of them early. You kind of have to wait and see what you have and then make it positive. All right, with that, I'm going to go ahead and close homework. Thanks to all of you guys that were working on homework last night. I was encouraging the juniors, like, hey, this is your chance to get ahead because we're going to go over 10-1 real fast. We're going to go over 10-1 real fast to make sure sophomores aren't totally left out with absolutely no coverage of it whatsoever, especially when I realized my microphone had died halfway in between. However, sophomores, can you tell that it wasn't a bad section? I mean, the title of it was lines, but it was new lines, right? It was new lines, like m equals tangent of theta, an angle between, and inclinations. It was new, it was different. And look, I even had this whole page for questions that we could have used, and I didn't. Anyway, section 10-2. Here we go. Woo! My artists! It's time for you to take a stand, to rise up. My non-artists, well, it's okay. My non-artists, it's okay. Ryan. I have napkins at the front. Oh. Well, I did have napkins at the front. A lot of runny noses. Here you go. Michael, what's up? If you could just leave it on the TA desk before you leave. They'll grade it next period. It'll be ready for you anytime during the day when you come in. Starting at lunchtime-ish. My non-artists. Don't stress. Basically, all you need is the little pink shape. Is the little pink shape with the name and the category. So all you really need is basic conics. I mean, besides the normal notes that are there. Basic conics. Who are the basics? Circle, ellipse, parabola, hyperbola. Circle. I mean, you could even just show it not slicing a double napped cone. But a circle is just going to be perfect all the way around. Ellipse is going to be a little squished, whether horizontally or vertically, a little squished. Parabola, you guys know what that looks like. Hyperbola is going to be like two parabolas, two branches. So you need the basic conics, and then you need the degenerates. Degenerates. No. Retweeting that one? Okay, so degenerates. Degenerate conics, ways of slicing a double cone and not getting one of the curvy shapes from up above. You could slice right through the center and just get a point. You could slice right along the side and just get a line. Or you could slice straight down through the middle and just get 2 intersecting lines. So my artistic ones, you can try to do the double cone and actually show the slicing. My non-artistic ones, totally fine. Just show the little pink ones with the names and then the categories. Cool? And then if you finish writing those, maybe go check out if your calculator has anything in it that might help with conics. Maybe you saw it last year. Maybe you didn't. You guys did see conics a little bit last year, right? No. What? I'm trying to think what he's doing this year. Right now, he was debating whether to go to conic sections after trig or probability, and I think he chose probability first. But there's still a month left of school, I would have imagined. Well, I'll ask him just to make sure. The second, degenerate conics. Degenerate conics is the second category. Basic conics is the top. You guys in Las Vegas? Oh, come on. You guys love making a bigger deal about things than they really are. Have you noticed that? Right now, juniors and sophomores, I don't know, there's some drama. You guys just... Oh, okay. Juniors?
More or less. I'm scared of the middle school.
Well, let's stop the recording now.
No, we're not going to go much further, but I do want you guys to think that usually, I mean, I don't know about you guys, and maybe this wasn't your experience when you were younger, but usually you look up to the upperclassmen in some way, shape, or form. And if you look around your class and you're like, they're looking up to us, maybe consider not just your own class, but consider others too, as to they need good examples. And sometimes that can be motivation to fight for what's right, even if you don't want to do it for yourself, but to do it for someone else. But anyway, kiddos, we're going to start section 10.2. And the crazy thing is, this page looks super overwhelming. Did anybody find anything in their calculator, even though we were talking about life a little bit? Did anybody find anything in their calculator that has anything to do with conics? Apps. And it's called conics. Apps, and it's called conics. And I'm not sure if it's on the old calculator. Sorry, my yellow button people. Apps, and it's called conics. I'm showing it to you because it's there, and it kind of gives you like the general forms for each. But guys, let me just warn you right now, there's so much more to learn than that right there. So we need to know how to use it, but it's cool that it's there, and you're going to be able to use your calculator. So once we get to these problems, we will look at it, we will know how to use it, etc. But there's more to know than that, I promise. Nice thing is, guys, section 10.2, what's the title? Intro to conics, okay, intro to conics, but, I mean, it's worse than lines, but it's not too much worse, right? Parabolas. So we have all of this stuff. We'll come back to all this stuff. We're going to talk about circles and ellipses in 10.3. We're going to talk about hyperbolas in 10.4. We're going to be maybe tripped up a little bit by the degenerates every now and then in 10.2 and 10.3 and 10.4. But right now it's time to talk about a parabola. So parabolas, let's review. Where have we been with parabolas? Well, we used to, We used to talk about parabolas using y minus k equals a times x minus h quantities squared. Another way of writing that, y equals a times x minus h quantities squared plus k. Back in the day, I called this the new standard. Because it was so important, we made it the new standard. And we had to do things like complete the square to get there. Ooh, it's coming back. It's all coming back. Never mind. So, new standard. Here's the dilemma. This was great back in the day, and it's still good, and it gave us the skills that we're going to need, but actually we need to go to this new form where we kind of rearrange stuff. But if you can, and if we can review how to do this form, we'll be fine. We'll be fine. Quick deals with the orientation of parabolas. If we have a positive coefficient, that means multiply. That's not add or subtract. Multiplying by the x squared or multiplying by the y squared. If we have a positive coefficient, then we're going to be having a concave up like a cup. If we have a negative coefficient, we're going to be having concave down like a frown. Negative person, positive person, smile, frown, however you want to remember it. We've been here, we've done that. This talks about the A, right? If A is positive. Every time someone yawns, I want to say bless you, but it doesn't really work. But still, oh, bless you. And shush. Okay, so parabolas don't just go up and down. They could always go, or they could also go. Right would be with a positive coefficient, and left would be with a negative coefficient. But these formulas look a little bit different, because these top ones look like y equals ax squared. But this one would be x equals ay squared. Ooh, the squared is somewhere else. This one, still y equals ax squared, but a is negative. And still x equals ay squared, but a is negative. Don't know why it felt weird when I said it. But here's the dealio. We have to cover something called a focus, and something called a directrix, and something called a clue form. Not just a vertex form or a standard form, but the clue form. Define a focus and define a directrix. Each of these little baby parabolas are going to have a focus point that's inside the concavity and a directrix that's outside. A focus point that's inside the concavity, a directrix that's outside. A focus that's inside the concavity, a directrix that's outside. A focus that's inside the concavity, and a directrix that's outside. But here's the dealio. To get to the focus from the vertex, you're going to have to go this new variable p. But we have an a, but the a is going to somehow become a p, but we're going to have to do some work to get there. And why on earth would we need something called a focus? Have you ever heard of a parabolic reflector? Have you ever seen a flashlight? Have you ever seen one of those old school flashlights that when you unscrew to get the whole big old batteries in the handle, it has like that curvature and there's that little baby light bulb? Guess how parabolic, the flashlight, how parabolic reflectors work. A lamp, just the light goes out, right? A flashlight, the beam is directed, true? Why is it directed? The parabolic reflector. And where does the light need to go to reflect correctly? At the focus. The little light bulb needs to be at the focus to properly reflect. Cool, kids. 10-2 parabolas tomorrow. I think our time is done. It's been fun. Pursue good choices. Love on people around you. Keep on remembering grace and forgiveness because God gave it to us. Bye, guys. Jacob, I'm coming. Let me pause the video.